Hi, this is Tom, and this is lesson 20, the normal distribution. Now, in our last video, or last lesson, what we did is we talked about the standard normal distribution, and we'll write that. We looked at the standard normal distribution. And we said that you could denote it or represent it with the symbol n for normal distribution, parenthesis 0 because that was the mean, comma 1 because that was the standard deviation. So today what we're going to do is we are going to look at what happens when it's not the standard normal distribution, but just a normal distribution. That's what we're going to do today. Normal distribution. And we denote it this way. We denote it as the normal distribution with some mean, x bar, and some standard deviation, s, or sometimes even Sn, depending on the way it's calculated. You might also sometimes see it as n with mu for the mean and sigma for the standard deviation. So let's see how this applies. I'm going to begin, and we're going to do, let's look at this. The average, or let's do this. Let me rewrite that. The height H-E, goodness gracious, the height of adult American males is normally distributed with a mean of 5 feet 10 inches and standard deviation, I'm just going to abbreviate that S dot D dot, and standard deviation of 4 inches. So first, you want all of your units to be the same. So let's convert 5 feet into inches. And so if you have, it may have been a while, but many of you may already know, it's very simply, you just take the 5 feet, or I should write it, if you're in chemistry, you might use a proportion, you might multiply it by the fraction of, there's 12 inches in every 1 foot, so the feet would cancel. 5 times 12 is 60 inches. And so if someone has 5 feet 10 inches, that's the same as saying that you're 60 plus 10 or 70 inches tall. Okay, so in other words, the normal distribution that represents the adult American male is represented as n, the mean of 70, and a standard deviation of 4. So we're going to take a look and we're going to draw that picture. So I'm going to come down here and we need some space. So let's see. There's my mean. And I'm going to put a, right here in the center. Looks, oh, it's a little bit off. Let's try that again. Okay, and then I'm going to sketch my normal curve. Hopefully it comes out reasonably symmetrical. I always find one side is easier to draw than the other. Hopefully yours even nicer looking than that. Oh, that'll work. It's kind of ragged there towards the top. Okay. Now, when we look at this, remember this is no different than the standard normal distribution. Again, the mean goes right in the middle. And now when we talk about standard deviations, well, instead of using units of 1, well now, remember the standard normal distribution, we would have gone 1, 2, 3 standard deviations to the right, and 1, 2, 3 standard deviations to the left. Well, the picture is exactly the same. But now, instead of a standard deviation being 1 unit, it's 4 units. So the next place, if I start at 70 and I move to the right, I would take 70 and I'd add 4 to get 74. And to get to the next standard deviation, I would add another 4, so that's 78. And then the next one would be 82. And then going the other direction, if I start back at 70, I subtract 4, that'd be 66. If I did that again, I would be back here at 62, and then subtract another 4, and that would take me to 58. And so this is the normal distribution that represents the heights of American males. So let's try this. We're going to use our picture here, and we're going to tackle a few questions. And the first one is what percent, and I'm going to abbreviate, what percent of males are less than 70 inches tall? Okay, that's going to be the first question that we deal with. So what I'm going to do is I'm going to need, this is a nice picture, and so we don't have to draw it too many times. I'm going to copy it. I'm going to bring it down here so I can use it again. Put it there. Okay, so let's go back up here. Now, what percentage of males are less than 70 inches tall? Well, let's take a different color here, maybe our pink highlighter, and I'm going to highlight everything below 70. Well, if I start doing that, I end up doing quite a bit of coloring. And I like coloring, so that's not a problem. But I would color all of this. Now notice that 58 is 3 standard deviations below the mean, but I would continue even past that. And so notice then that the curve is symmetrical. So everything below 70 is exactly half of the curve. Everything below 70, this is exactly half the area under the curve. And that's our answer. So what percentage of males are less than 70 inches tall? We represent half as 50%. Okay, so let's try another one. Let's do another one here. How about this? What percent of males are above 6 feet 2? Okay, this is a good question. All right, what percent of males are above 6 feet 2 inches tall? Question mark. Now, in order to do this, I'm going to come down here and let's pick up a copy of this normal distribution. So I'm going to copy that. I'm going to bring it up here so we can put it to good use. Oops, that didn't work like I'd hoped. Okay, so I'm going to paste that, bring it down, and we'll put it right about there. Now, when we work on this one, notice that we don't have 6 feet 2 inches in here. So the first thing we need to do is take that 6 feet, and we're going to multiply it by 12 inches for every 1 foot. So the feet would cancel, and 6 times 12, that's 72. So a person that's 6 feet 2 inches. Well, 6 feet is 72 inches, plus the other 2 inches. That's 74. That is 74 inches tall. So that's a fairly tall person. Okay, now let's see. Do we have a, look at that. There happens to be a 74 in our picture. So let's take a look at 74. So if I draw a line above 74, what I want now is all of the people that are above. Well, above 74, that's this entire region here. All of these people are above 74 inches tall. So I'm going to move this back down. And down here, okay. Now, let's take a look. So to finish this problem, well, now we have to do a bit of work. And what we're going to do is we're going to have to use the empirical rule. And remember what this says. It says that within 1 standard deviation above and below, well, that's 68% of the data. I think we could keep going. 2 standard deviations is 95, but look at our 74 lands right at 1 standard deviation. So let's think about this. In the problem that we just did, in the problem above, we said that this region right here is half, that this is 0.5 or 0.50. Now, we've also said that if I go a standard deviation above and a standard deviation below, then this blue region, well, that represents 68% or 0.68. But wait a minute. Part of this blue region, we just want the half of the blue region that's right there. And now you can see how the problem might happen a couple different ways. So half of 68, this area right here, this is 0.34, or half of 68%, or 34%. Now, you can do this 2 ways. You could say that, well, wait a minute. I have 50% here plus 34%. So let's see what that is. If I take 0.50 plus 0.34, that's 0.84. But that's not what we wanted. We want the green region. Well, the green region, if we shaded everything, we'd shade 1. But let's subtract what we don't want, the 0.84, and we left with 0.16. Another way you could look at this is this way. Say we have the blue region here is 0.34. And I know if I shade the entire right half, say I shaded all of this region, well, then I would shade 0.5. So then another way is I could say, if I shade the entire right half, that's 0.5. And then if I subtract the piece that I don't want, the 0.34, well, then that would give me my green region, which is, again, 0.16. So there's 2 different approaches to that. The real key, in my experience, is make sure you take some time and draw a nice picture and shade the parts that you're after. And if you have colors, that helps, or maybe grayscale or different sketching, hash marks. The clearer your picture, I think the clearer your understanding of how to solve the problem at hand. Okay, let's try one more problem. And look at that. We have exactly one more normal distribution right here just waiting to be utilized. So we'll straighten that out, maybe make it even a little bit bigger and straighter. Okay, here we go. So let's go back to our gray. And this problem says, it says 95% of males are found between what heights? Okay, well, I could probably make my F look better. There. So that might help the whole problem. Let's take a look at this. This one actually becomes a direct application of the empirical rule. So it says, remember, that if you're one standard deviation above and one standard deviation below, well, that's 0.68 of the curve. And then it says that if you take it another step and you go 2 standard deviations above and 2 standard deviations below, well, that's 0.95 of the curve. But wait a minute, that's what the question was asking. So now we can just come here and we can look down, and there are our heights. So we could say male, 95% of males between what height? The answer would be 62 inches to 78 inches. And let's say we wanted to convert those back into feet and inches, because that's the way most of us would share our height with someone. We would say that they're 5'10" or 5'8" or something like that. So let's do that. Here's how we do this. We take our 62 and we divide it by 12. Well, 12 goes into 62 5 times. 5 times 12 is 60. We subtract the 60 and we get a 2. So we have 5, remainder 2, and that's the answer. The answer is 62 inches is equal to 5 feet 2 inches. And let's do that again. And 78, take that, we divide it by 12. 12 goes into 78, I think it's 6 times. So 12 times 6, that's 72. Subtract, that's 6, and there's my answer. So this would give me, so I have a remainder of 6, so I would say that 78 inches is equal to 6 feet 6 inches. And that is how we apply the empirical rule and make the transition from the standard normal distribution to the normal distribution. Hope that helps. Thanks for watching.